Today, we're going to skip the deep technical jargon and get right to the point. We're breaking down a financial strategy, a blueprint really, that managed to slash data infrastructure costs by a staggering 80%. This is all about translating a complex tech migration into a language that really matters to the bottom line: cost, risk, and of course, return on investment.
So everything really starts with this chart right here. For a business like an online ticketing platform, demand isn't some gentle, predictable wave. It's a series of massive, unpredictable spikes. You know, a new movie comes out, a huge concert is announced, and bam! Traffic can jump 10, 20, even 100 times what it was just minutes before. Now, in the old world, you had to pay for an infrastructure that could handle that absolute peak moment, 24/7. That means for 99% of the time, you were just bleeding money on capacity that's sitting completely idle. This isn't really a technical problem, it's a huge financial liability.
And this quote just perfectly captures the core problem. The old systems, these monolithic architectures, they tied two totally different things together. Compute power, that's your engine, and your storage capacity, the trunk. So if you needed to store more data for historical analysis, you were forced to buy a much bigger, much more expensive engine to go along with it, even if you rarely needed all that horsepower. It's just a fundamentally broken model that forces you to constantly overspend.
What we see here is the fundamental shift in the financial model. On the left, you've got the legacy system. Think of it as a massive fixed cost. It's a capital expenditure. You're buying servers for the absolute worst-case scenario. But on the right, the modern approach flips that script entirely. We're moving to an operational expenditure model. Costs become variable. They scale up and down, almost to the second, right along with demand. By breaking that link between storage and compute, we go from incredibly high waste to super high efficiency. You literally only pay for what you use, right when you use it.
Okay, so that all sounds great, right? But how do you actually build an architecture that thinks this way, that aligns cost with demand? Well, the solution wasn't just about grabbing the latest and greatest technology, it was about being intentional, designing a system from the ground up to solve those very specific financial challenges we just talked about. And here is that blueprint. It's a lake house architecture. First, all data, no matter the source or format, lands in one central place, Amazon S3. Think of it as a massive, super low-cost data lake. This single move decouples storage from everything else. Then we use serverless tools for all our data processing, which means we're not paying a dime for idle servers. A really key piece here is the AWS Glue Data Catalog. It acts like a central map or a universal translator for all our data. It's not just a list of tables, it's what allows all our different tools to find, understand, and securely access the data. And finally, we wrap the whole thing in a centralized governance layer to keep it secure and compliant. Every single step here is a strategic financial decision.
Let's dig into a few of those technology choices because each one has a direct financial justification. We chose Amazon Redshift RA3 nodes specifically because they fully separate compute from storage. This lets us spin up massive analytical power for really heavy queries, but without having to pay to store petabytes of data on those expensive warehouse nodes. Then there's AWS Glue. The magic word here is serverless. This decision alone completely eliminated the cost and the headcount of a dedicated team that used to just manage and patch a complex Spark cluster. And for the really big jobs, we use Amazon EMR. But we run it on what are called spot instances, which is basically tapping into spare AWS capacity at up to a 90% discount. It's a huge lever for cost savings. And this right here, Redshift Spectrum, is a total game changer for the economics of data retention. It allows your high-performance, expensive data warehouse to query data that's still just sitting in your cheap S3 data lake. Think about it. You might have years of historical logs that you need for compliance, but rarely touch. Instead of paying to keep all of that in your most expensive storage tier, you just leave it in S3 and pay only for the few seconds it takes to run a query against it. It fundamentally changes the cost equation for long-term data archival. All right, let's get to the payoff. We've seen the strategy, we've looked at the tools. Now let's break down exactly how this intentional design led to that incredible 80% savings figure we've been talking about. The savings didn't come from a single silver bullet. It was a multi-pronged attack on waste. As you can see, a huge chunk of it comes from using those deeply discounted spot instances for our heavy data processing. Another massive driver is automated S3 tiering, which intelligently moves data to cheaper and cheaper storage classes over time. And finally, you've got the raw efficiency of serverless tools like Glue, where you literally pay nothing for idle time.
And there it is, the result of all these strategic decisions, all architected together, an 80% reduction in the total annual cost of the entire data platform. That's the number that completely changes the budget conversation. A big part of that 80% comes from just being smart about storage. And here's how it works. You just set up some simple rules. Active, hot data, it stays in S3 standard. But after, say, 30 days of not being touched, an automated policy moves it to a cheaper tier. After a year, maybe it moves again to the ultra-low-cost Glacier archive for long-term storage. The best part is this is all fully automated. You set it and forget it, and you're always using the most cost-effective storage without anyone having to lift a finger.
Okay, but saving money is pretty meaningless if your data isn't secure, right? A data breach can be one of the most expensive things a company ever faces. So let's work at how this new architecture converts security from being just another cost center into a powerful risk mitigation strategy that has a clear financial value. The secret weapon here is AWS Lake Formation. Instead of juggling complex permissions across a dozen different services, Lake Formation gives you a single pane of glass, a single control plane. It's one place to define who can see what data, from the raw files landing in the lake all the way to the polished tables in the warehouse. That simplicity is, in itself, a massive security and cost-saving feature. It reduces human error and makes things like compliance audits dramatically easier and faster. And this is how we prevent those costly incidents. With column-level security, we can give an analyst access to a sales table so they can see transaction amounts, but we can completely block their view of the customer's name or their credit card info. With row-level security, a manager in Europe only sees European data, period. This granular control isn't just a nice-to-have, it's absolutely essential protection against breaches and fines that can run into the millions. Now, to make sure our data is reliable, we use a really structured pipeline, often called a bronze, silver, and gold layered approach. Raw data lands in bronze. It's then cleansed and standardized into a silver layer. Finally, it's aggregated into business-ready gold datasets perfect for analytics. This whole assembly line is orchestrated by a tool called Apache Airflow, which ensures it runs like clockwork every single time, with those security policies from Lake Formation being applied at every single stage.
And I mean, the results just speak for themselves. The legacy system had really inconsistent pipeline success, which translates directly to cost. Every time a pipeline failed, it meant engineers were pulled off of building new things just to firefight. It meant that business leaders were making decisions on old, stale data. The modern, orchestrated system, it achieves a success rate of over 99%. This isn't just about operational stability, it's a direct reduction in the hidden painful costs of downtime.
So let's bring this all home. We've looked at the strategy, the execution, and the results. Now we're going to frame this whole thing as a clear, concise return on investment summary, exactly the kind of thing you can take into your next budget meeting.
Look, this table is the entire business case on one slide. We went from high fixed annual costs to costs that are 80% lower and move with the business. We massively reduced the financial risk of downtime. We boosted pipeline reliability to near perfect. And maybe most importantly, we completely changed the speed of innovation. We even extended this variable cost model to our BI tools, using things like QuickSight, which gets rid of expensive per-user licenses.
But, perhaps the most important ROI isn't even on that table. This whole transition, it wasn't just technical, it was cultural. We shifted the focus of our most skilled, most expensive people. They're no longer spending their days patching servers and just keeping the lights on. Because the platform is now so automated and serverless, their focus has moved from maintenance to innovation. They are now free to build the data products and find the insights that are actually going to drive the business forward.
So the final question really isn't about what we saved. It's about what we can now achieve. This project didn't just cut an expense line on a spreadsheet. It liberated capital. It created a brand new pool of funding for future growth. The conversation for next year's budget is no longer about how to manage costs. It's about how to invest in the next wave of innovation funded directly by the efficiencies we just created.